This is the video for Module 13, Section 7.5, about solving equations containing rational expressions. First of all, one thing that can be very confusing is whether you have an equation that you're supposed to be solving or just an expression that you're supposed to be simplifying. So let's look at the difference between an equation and an expression. You can tell an equation because it contains an equal sign. So for example, here's an equation that has some rational expressions in it. The thing that tells you you have an equation to solve is the equal sign right here. So this one you would be solving for x, because that's the variable. Now an expression doesn't have an equal sign. So here's an example of an expression. Notice that there's no equal sign in here anywhere. So the only thing that you can do with this one is just simplify. In this case, you would want to find a common denominator and go ahead and add the two rational expressions, but you wouldn't be able to solve it for anything because there's no equal sign. So what we're talking about in this section is actually solving equations. If you have an equation that contains rational expressions, then your first step is to find the LCD of all the rational expressions in the equation. The second step is going to be to multiply each rational expression on both sides of your equation by the LCD that you found. And third, go through and simplify each different rational expression by canceling common factors. The advantage to using this method for solving equations is that when you multiply all those rational expressions by the LCD, that means you'll be able to cancel factors from the LCD with factors in the denominator of each rational expression, and it will actually clear out all of your fractions. So once you've done that, you should end up with an equation that has no rational expressions left in it, and you can just go ahead and solve it. And the last step, this is very important when you're solving equations with rational expressions, is to check all of your solutions. And you have to go back to the original equation to check your solutions. The problem is that you may end up with a solution that doesn't work in the original equation. It may be one that makes the denominator equal to 0 in one of the original rational expressions. Let's go through some examples. So remember, we're not actually rewriting each rational expression with the LCD. We're just finding the LCD, and then we're going to multiply through by that LCD. So in this one, our rational expressions are x over 3 and x over 9. The 3 is already prime. The 9, if we write its prime factorization, is 3 times 3. And remember over here, the 8 is actually the numerator. We could rewrite this as 8 over 1 to make it look like a rational expression. So our LCD is just going to be 3 times 3. So now what we're going to do is we're going to take that LCD and we're going to multiply it times each one of these three rational expressions. We have to do the same thing on both sides of our equation, and any place that we have a plus or a minus in between rational expressions, that means that we have two different terms, and we have to multiply the LCD times each one of those separately. So we have 9 times x over 3 minus 9 times x over 9 equals 9 times 8. So there we've taken our LCD times each one of those terms. Now we're going to do cancellations. And as I said before, if we've chosen the right LCD, we should be able to cancel common factors so that it takes out all of our denominators. So here we can cancel the 3 and the 9 up here. So it leaves us a 3 in the numerator. Here we can cancel the 9s, both of them. And here we're not canceling anything. So we end up with 3x minus x is equal to 9 times 8, which is 72. Now we just have a fairly simple equation to solve. We've gotten rid of all of our fractions that we had. So we'll combine terms here. That gives us 2x is equal to 72. And then to solve this from there, we're going to divide both sides by 2. That gives us x is equal to 36. An important part of solving a rational equation is to check your solutions. So we're going to take this 36 and go all the way back up to our original problem up here. And really what we're checking for here is to make sure that the 36 doesn't give us 0 in the denominator. But it's a good idea anyway, just to check your solutions and make sure that you didn't make an arithmetic mistake. So 36 divided by 3 is 12. 36 divided by 9 is 4. So that gives us 12 minus 4, which is 8. So that checks. That means that our solution is x equals 36. All right, now let's try this one. In this one, actually, we only have one rational expression. We have this first one right here. We can rewrite these two using a 1 as the denominator. So our LCD, since we only have the one rational expression, the LCD would just be the denominator from that one, which is 5. So now we're going to take 5 times each one of these terms. So we have 5 times the 4x over 5 minus 5 times 8. And it's easy to forget that you have to do this on both sides. But remember, we're just solving an equation. So whatever we do to this side, we also have to do to the other side. Now we can cancel the 5's here. That gets rid of our one denominator that we had. So we have 4x minus 40 equals 5x. And now we're just solving the equation. So if we subtract 5x from both sides, we have a 0 over here. And then if we add 40 to both sides, that leaves us with just negative x here. So we have negative x equals 40, and then if we multiply both sides by a -1, that gives us x equals -40. So again, we're going to go back and check our solution in the original equation. So we have to come all the way back up here. And then we're just substituting -40 for the x. So 4 times -40 is -160. Oops, minus 8 equals -40. 160 divided by 5 would be -32. And if we take -32 minus 8, we're going to get -40. So that checks. And again, that means that the solution we got is a good one. So our solution is x equals -40. Okay, in this one, notice that our second denominator here has a common factor of 2. So let's go ahead and factor this. If we factor out the 2, we get 2 times x minus 4. So when we're looking for our LCD, now we have two different factors. We have the x minus 4 that occurred once in each one of these, and the 2. So our LCD is going to be 2 times x minus 4. And again, we would be looking at the LCD on this side if we had a rational expression. Now we're going to multiply each one of these three terms by our LCD. So we have 2 times x minus 4 times 4 over x minus 4. And I'm writing this denominator in parentheses so that we know it's a factor. And then here we have the 2 times x minus 4 times 4 over, and we're going to write this one in factored form so that we can easily see what we can cancel. And then over here we have 2 times x minus 4 times the 6. So let's cancel out what we can. We have the same factor of x minus 4 here, so we can cancel that. Here we have both of the factors, the 2 and the x minus 4, that we can cancel. And over here we're not canceling anything. So what we have left is 8 from that one, and here we just have 4. And on the other side, we're going to have to multiply this out. If we multiply the 2 and the 6, we have 12 times x minus 4. So now we have 12, and if we distribute that 12 over there, we get 12x minus 48. If we move the 12x over to this side, that gives us negative 12x plus 12 equals negative 48. And then if we subtract 12 from both sides, that gives us negative 12x equals negative 60. If we divide by negative 12, then we get x is equal to 5. So again, we're doing our check. So we're going back to our original equation up here and putting in 5 in place of the x. So 5 minus 4 there, plus 4 over 2 times 5 minus 8 is equal to 6. So here this gives us 4 over 1 plus 4 over 2 equals 6. So that would be 4 plus 2 is equal to 6. So that one checks. So our solution is going to be the x equals 5. Okay, in this one, notice that we have a rational expression on each side. We also have this whole number in the middle, so we can write that as 6 over 1. So our LCD is just going to be the x minus 7, since that's the only factor that we have. So we're going to take the x minus 7 times x over x minus 7 plus x minus 7 times 6. We have to do the same thing on this side, so we'll have the x minus 7 times 7 over x minus 7. Now we can cancel our common factors here, and we can cancel our common factors over here. So now that took out all of the denominators we had. So what we have left here is x. Here we have x minus 7 times 6, and on the right side we have a 7. Now we're going to distribute our 6 into here, so we have 6x minus 42. If we combine terms here, we get 7x minus 42 equals 7, and then if we add 42 to both sides, 42 plus 7 is 49. So then we're going to divide both sides by 7, and that gives us x equals 7. So now we're going to check. Again, we're going back to our original equation. So if we put in 7 in place of x here, we get 7 over 7 minus 7 plus 6 is equal to 7 over 7 minus 7. Now here we have a problem, because in both of these two denominators, 7 minus 7 is going to give us 0. That means we've got division by 0, which is undefined. So what that means is that the solution we came up with doesn't work in our original equation. So we have to throw out this solution, and that means that we don't have any solutions. So for this one, we would have to say no solution. This doesn't mean that we made a mistake, it just means that the solution we came up with worked in this equation, but it didn't work in our original equation. Okay, one more example. In this one we have two rational expressions here, and we have one on the right side that we actually can factor. Notice that m squared minus 25 is the same as m squared minus 5 squared. So we can factor this as the difference of squares, which gives us m plus 5 times m minus 5. So for our LCD, the two different factors that come up are the m plus 5 and the m minus 5. They both occur a maximum of once in any one of our denominators. So that's our LCD, is just the product of those two. So we're going to take that LCD times each one of our rational expressions. And remember to also do this on the right side, because you have to do the same thing to both sides of the equation. And for this denominator, I'm going to write it in factored form so that we can see which factors to cancel. Okay, now we do our cancellations. So here the common factor is m plus 5, so we're going to cancel that out. Here the common factor is the m minus 5. And here it's both the m plus 5 and the m minus 5. So we can cancel out both of those. Now what we have left here is a negative 2 times m minus 5. What we have left from this one, there was a minus here, so we have a minus 3 times m plus 5. And on the other side, the only thing we have left is the 15. Now we're going to distribute the negative 2 here, so we have negative 2m plus 10. Here we're actually distributing a negative 3, so we have negative 3m minus 15. And if we combine terms here, we have a minus 5m minus 5. If we add 5 to both sides, that gives us negative 5m is equal to 20. And then if we divide both sides by negative 5, we get m is equal to negative 4. Now again, it's very important to do our check. So we saw in the last problem that we can end up with solutions that don't actually work. So we're going back to our original equation, and we're substituting the negative 4 in place of the m. So we have negative 4 plus 5 minus 3 over negative 4 minus 5 equals 15 over negative 4 squared minus 25. Now in this one, you could use this denominator either the way it was originally or in the factored form. We hadn't actually changed anything yet here, we just factored it, so whichever way is easier for you. So here we would have negative 2 over 1. This one we'd have minus 3 over negative 9 is equal to 15. And here, remember, if you square a negative 4, if it's in parentheses like this, you're going to get a positive 16 minus 25. So this is negative 2. We have two negatives here, so that's going to give us a plus. And we can cancel the 3 and the 9, so that gives us 1/3. And then here we have 15 over negative 9. And that we can cancel the 3 out of there, so that gives us a negative 5/3. Now if we rewrite this one as negative 6/3, so that we can combine it with the 1/3, then we'll see that negative 6/3 plus 1/3 is going to give us negative 5/3. So that one checks. So our solution again is m is equal to negative 4. Now there are some special cases of rational equations that we can use a shortcut with. In some places you'll see this talked about as using the cross product, and I just call it cross multiplication. It only works in one case though, and that is when there's a single rational expression on each side of the equation. So the only way that this can work is if we have one rational expression on one side of the equation and one rational expression on the other side of the equation. So here are some examples of equations where we could use this method. Notice that in each one, we only have one rational expression on each side. And all we're going to do with this cross multiplication is we're going to multiply each numerator by the denominator on the other side of the equation. What that's going to look like, for instance here, we would multiply the 7 times the x plus 4, and here we will multiply the x minus 3 times the 3, and then we just make those two cross products equal to each other. So that's our cross multiplication. Over here it would look like x minus 5 times the 7 equals 10 times x minus 2. Now we could get the same thing by using the other method we talked about, using the LCD. This is just a shortcut. So once we get done with this, then we can go ahead and solve the equation. And again, since we started out with a rational expression, our last step in doing this is going to be checking all of our solutions. So let's do those two examples that we had on the last page. Here we have the x minus 3 times the 3. Then we're going to have an equals, and then here we're going to take the 7 times the x plus 4. Now all we have to do is distribute our 3 over here, so that gives us 3x minus 9, and our 7 on this side, which gives us 7x plus 28. Then to solve this, we're going to subtract 7x from both sides, and we're going to add 9 to each side. So that gives us negative 4x equals 37. So x is going to equal, if we divide by negative 4, x is going to equal negative 37 over 4. Now we'd want to check this, and again we have to go back to our original equation. So we're substituting negative 37 fourths in place of the x. Now the main reason for checking these is to make sure you're not getting 0 in any denominator. So since this involves some kind of nasty fractions, I'm not going to go any farther than this for this check, because we can see we're not going to get a 0 in either denominator. It would be a good idea to go ahead and check this for yourself, just to make sure that there weren't any arithmetic mistakes up here. But I'm not going to take the time to do that in this video. Now for this one, again, if we're doing the cross multiplication, then we're going to take the 10 times the x minus 2. And on the other side of the equation, we have x minus 5 times 7. Now we just have to distribute. So over here we have 10x minus 20. Over here we have 7x minus 35. Then if we subtract the 7x from both sides, and if we add the 20 to both sides, we end up with 3x is equal to negative 15. So x is equal to negative 5. All right, now we're going to do our check. So we're taking the negative 5 and putting it back into our original equation. So we have 10 over negative 5 minus 5 equals 7 over negative 5 minus 2. So here we have 10 over negative 10. Here we have 7 over negative 7. And this one's pretty easy to simplify on each side. We get a negative 1 from here and a negative 1 from here. So this one we can see that it checks, and that means that x minus 5 is our solution. One more thing that we can run into with rational expressions is that sometimes we have an equation with several variables and we're trying to solve it for one of the variables. We're still going to use the same method for this, which is multiplying both sides by the LCD. So for example, if we want to solve the equation 1 over a plus 1 over b equals c for b, then we would use our LCD, which would be a times b. So since this is c over 1, then the only two factors in our LCD would be the a and the b. So the LCD is just ab, and that means we're going to take ab times each of our three terms on the two sides of our equation. So we have ab times 1 over a plus ab times 1 over b equals ab times c. And now we can cancel. And since these are all multiplications here, that means we can cancel our factors. So here the common factors are a, and here they're b. What we have left here is b times 1, so that's just b. What we have left here is just a, and over here we have abc. Now this is where it's important to remember which variable you're solving for. In this one we were solving for b. So now what we want is to get all of our b terms on one side of the equation and all of the non-b terms on the other side. So all of our b terms, in other words, any term that contains a b, I'm going to put all of them on the left side, and all of the non-b terms, in other words, terms that don't have a b in them, on the right side. What that means is that this term needs to move over here, and this term needs to move over here. So if we subtract the ABC from both sides, then we have b minus ABC, and then if we subtract the a from both sides, then on this side all we have is a negative a. Now the reason for doing that is that now that we have all of the b terms on this side, they all have a common factor of b, and we can factor that out. So now what we're doing is factoring out the b on the left side of our equation. So we have b times 1 minus ac. Remember, if you have a term like this and you're factoring out everything that's there, you still do have a 1 left. What we're trying to do is solve for b, so now we can divide both sides by this whole factor of 1 minus ac. So now we're going to divide by the factor that we have left. On this side, the 1 minus AC's are going to cancel. So we just have the b, and on this side we have negative a over 1 minus AC. So we have the b by itself on this side, no b's at all on this side, which means we've solved for the b. Let's do another example. In this one we have f equals negative g mm over r squared, and we're trying to solve for m. So let's go back to our LCD method. The LCD for this, since we only have the one rational expression, the LCD would just be r squared. So we're going to multiply both sides of this by r squared. So over here we have r squared times f. Over here we have r squared times our whole rational expression over here. Now we can cancel the r squareds on this side. Again, since this is all multiplication, we don't have to worry about terms. Everything here is a factor. So what we have left now is r squared times f equals negative g times capital M times lowercase m. Now what we were trying to solve for was the lowercase m. And this one, again, since we don't have any terms, we can just go ahead and divide out the factors on this side to get our m by itself. So the ones we're trying to get rid of here are the g and the capital M. So we're just going to divide both sides by that. On this side, all of that's going to cancel, including the negative, since we divided by the negative. So now we have r squared times f over negative g times capital M equals m. And we've got our solution. We have solved for the small m.